Okay, this lecture is going to be about the difference between strong acids and weak acids, okay? Now, a lot of times what you probably are thinking of when you hear the word acid, you're probably thinking like, oh, it dissolves through the countertops and all this stuff. Where that is true. Some acids have different tendencies than other acids. Okay, so just because it's a strong acid doesn't mean it's going to burn through the table, okay? So we're actually today going to talk about what's the difference between a strong acid and a weak acid. And there are really only 6 strong acids. There's more strong bases, but we'll talk about those when we get to bases. But the 6 strong acids that there are is hydrochloric, and it's acid, okay? Hydrobromic, acid. And I always mispronounce this one, idoic acid. There's also nitric acid, sulfuric acid, and then the last one is perchloric acid. Okay, so those are the only 6 strong acids there are ever, okay? Every other sort of acid, so like acetic acid, which you find in vinegar, citric acid, which you find in your citrus fruits, all of those acids are considered weak acids. So what does it mean for an acid to be strong, okay? Well, if we look at this equation that I have here, again, HCl is a strong acid. And we'll notice that HCl, when we put it in water, there is only a forward arrow. So what that means is hydrochloric acid is going to completely ionize when we put it in water, meaning it donates every single one of its protons, okay, which then gives us a lower pH because there's more protons in solution. So if I had a beaker of HCl and water, the only ions that will be in the beaker will be these ions. Notice how there's no HCl compound and water compound left. The only compound that I have are these, okay? So a weak acid, so these are just a few weak acids. So this is carbonic acid, it's a weak acid. This is nitrous acid. This is phosphoric acid. This is hydrofluoric acid. And then the last one is acetic acid. And these aren't all of the weak acids. There's tons more. But you do need to know that those 6 are the only strong. So you'll notice that for a weak acid, it doesn't completely dissociate. So again, you'll notice that this is a reversible arrow. So that means I can make H3O plus F minus, and I can make HF and H2O, okay? So if I had a beaker and I put HF into water, I will have H3O plus and F minus, but I will also have HF and water molecules, okay? So where we say strong acids 100% dissociate, weak acids only minimal dissociate, okay? So that means that this hydrogen hasn't been donated, so the pH is going to be a lot closer to 7 than it would for a strong acid, okay? And the same thing is going to hold true for the difference between a strong base and a weak base is the dissociation, okay? So some strong bases that we deal with are sodium hydroxide. And then I'll just say that this is obviously potassium hydroxide. Okay, and then there's others like calcium and magnesium hydroxide that don't really dissolve well, but they are considered strong. Okay, so like with Tums and milk and magnesia, when you get heartburn, the reason why you take those things is it actually neutralizes that that acid that you're putting up into your esophagus, and we'll talk more about that when we talk about neutralization reactions. Okay, so again, the same thing is going to happen. Notice only the forward reaction. So you're only going to have sodium ions and hydroxide ions in solution. Where with weak bases, again, you'll notice the reversible reaction, which means everything is going to be present when I mix this in water. So yes, I will have ions, but I will also have the starting compounds that I start with. Okay, so that's pretty much it for strong acids and strong bases. Thanks.